Now let's see how Seath will handle addition protocol executed on pre-production testnet. And first we will check the happy path, and it will go as follows. For users, we'll almost simultaneously send their actions to the leader. Leader accept them, build chain of transactions, and mark transactions as ready to be signed. Then each user will be monitoring the current state of his transaction, and when it will notice that transaction is ready to be signed, it will request transaction from the leader, check it, and if everything is okay, and in this case all users will respond positive that like everything fine with transaction, and then each user will sign transaction and send it back to the leader, and leader also sign all transaction in his turn and submits all transactions on chain successfully. So chain won't be broken anywhere, and everything just goes happy path. CLI for the demo define in test directory in main module, and this is related parts. There are two commands, one to run to start full leader node that I described in the previous section, which is start leader, and start users will start the scenario where user submits the action. I already showed the leader part, and at the user part here where action submission happens, first I creating 4 nodes here, and each node have like number from 1 to 4, just enumerated from 1 to 4, and this number will be amount of the add amount action. So each node will want to increment current state of the protocol by this amount depending on its number. And here we can see how we perform action submission, which under the hood will submit action to the leader. This will be like bridge between Seath and developers that gonna use the Seath to actually like submit the action to perform step on the protocol, either like from UI or from some automated environment. So in user scenario, we gotta submit 4 actions with add amount from 1 to 4, and then each user will monitor status of his transaction, and at the end we will be able to see like final results that user will save to the state. So let's one word to run Seath, because it uses Cardano transaction library under the hood. You will need a proper runtime with Cardano node and Kupo and Ogmios. There is an easy way how to start all this, and I will provide again details into the documentation. And now I just want to check that node is synced, and it is. So let's start leader node first. We see now that node is started, and web server part of the node is started on localhost on a port 3000, and now the leader starts listening for incoming transactions, incoming actions, I'm sorry, that come from the user, and as soon as the user will submit an actions, we will see like how leader and the users communicate. Let's start the users now. For happy path, things will happen quickly and there will be a lot of output. So we'll just wait while the work will be done and then trace back and go step by step of what was done on the leader and the user side. We're still waiting for users to start scenario for some time. It takes a while to launch. Okay, now as a quick recap, from the user's perspective, everything was successful. We can see here that all 4 users reports that their action was submitted and they no longer gonna track the status of this action. And we can stop user scenario and see result for each user that was stored into the user node memory. And on the leader side, there was a point in time when leader were waiting while a chain of transaction that it's just submitted is confirmed on chain. This is done because we cannot start building and submitting new chain before previous is submitted. Because if we want to wait till previous chain will be confirmed on chain, we will use invalidated state UTXO for the next chain, which still holds the old state. And as soon as leader confirmed that whole chain was like committed and confirmed on the blockchain, it started listening to incoming user requests again. And at this point, just stopped leader and we trace back and see how communication between leader and user actually happened. So here, before the user scenario is executed, we can see that current state of the addition protocol holds UTXO with the datum, and the current number is 5,751. And we have 4 actions submitted from the user, and actions are at 1, at 2, at 3, and at 4. So at the end, final state should be incremented by 10 and become 5,761. And we actually can verify it. We will need to get ID of one of transactions and go to Cardano scan, see if it's on Cardano scan, and it is. And from here we can see script address, and this is the address of the validator script which holds state of the addition protocol. And now I'm going to query node to see what is the current status of UTXOs at the script address. And here we can see the datum is exactly as what we expected, 5,761. So no actions were lost and all actions were chained and propagated to the blockchain to create new proper state without like any waiting or UTXO contention. So now let's go back and trace really fast what has happened on the leader and the user side. So here we can see that we start in scenario with 4 users, and each user sends its action to the leader, and gets initial action status to be processed -1. This is mean that action was sent successfully, but the user didn't query yet the real status using this ID it received from the leader. And on the next iteration, each user using this ID that it received from the leader queries the leader to figure out current state of his action. And now we can see that actions were added to queue, and the number, the position in the queue was arranged. And this is the order of the action in the future chain of transaction that leader will build. Meanwhile, on the leader side, we see logs that it receives request from the user to include action to the queue to build transaction over it. And here we can see all 4 actions that user submitted. This is add 1, add 2, add 3, and add 4. So all 4 actions were accepted by the leader, put to the queue, and with current config, as soon as leader gets 4 actions in the queue, it will start to process them. And we can see it on the user side. After leader accepted all 4 actions, user now receives the status of their action as being in process. And meanwhile, on the leader side, leader built chain of transaction. Here we can see that it picks a batch of actions to be processed, and this is IDs that it assigned to each action from the user. Now there is a bunch of status requests from the users that are not really interesting for us. And at some point, leader finishes building the chain, and it marks each transaction in chain as ready to be signed. And as soon as a user detects this status, we don't see it here because everything happened between 2 checks. But what happened that user detected the transaction is ready to be signed. It checks if transaction is okay, and current check returns always okay. And after that, each user signed transaction and send it back to the leader. And on the leader side, we can see that leader accepting these signed transactions and responds that it receives signed transactions successfully. At this stage, leader waits for a while, for some time period that is also configurable. It waits till users will respond with signed transactions. And when timeout is reached, leader first check if all transactions were signed. If not all transactions were signed, this means that chain is broken at some point. So what leader does in this situation, it will submit transactions that it can up to the point in chain where transaction was not signed. Transaction that was not signed will be removed from processing completely. And transaction after the breaking point will be scheduled for the next round of transaction building, of chain building and submission, and they will be put in priority queue, so they will be processed in priority during the next round of transaction chaining and submission. But this time everything went well. Leader logs here that it got 4 signed transactions. It checks that chain is not broken and reports that there is nothing to put in priority queue for the next round. and proceed to transaction submission. Here we see that 4 transactions were submitted. They were submitted one by one without waiting on confirmation as quick as possible. And there was no issues. And leader again shows here that there was no transaction in chain during submission that could like break those chain. So there is nothing to put in priority queue for the next round. And this is just a value that shows like total transaction that need to be prioritized after signing and submission, but during happy path execution there was no errors, so there is 0 here again. And after all transactions submitted to the chain, leader starts to wait while all transaction in chain will be confirmed, just because he cannot start build a new chain until previous will be confirmed. But from the user side, there is no waiting. User detects that transaction was submitted successfully, and Seath currently doesn't track any like rollbacks. So at this point, Seath framework doesn't track status of transaction any further, and it's up to the developer who gonna use Seath to like verify that transaction was not rolled back at some point of time. And so here we just see end results that each user stored in the memory that can be useful for the developer who gonna use Seath. And after chain confirmation is done, leader switch back to like listening for incoming actions. And that's actually it for the happy path. So for users submitted their actions simultaneously, there was no UTXO contention from one side, and users didn't have to wait while previous transaction in chain will be submitted. And at the end, all 4 transactions were executed, and I presume in a single slot, but we can, as in previous demo, like we can check a couple transactions to see. So the first transaction in chain was submitted in slot 126.090, and the last transaction in chain, yeah, it was submitted in the same slot. So that's it for happy path, and in the next section we'll see how chain get rebuilded and resubmitted if something goes wrong.